Hello, dear students. Today we have proposition 33 of book 3. 33, book 3. On a given straight line, to draw a segment of a circle emitting an angle to a given angle. Okay? So here we're going to have three possibilities. Alright, it's the same given straight line, just three different possibilities. The angle given is acute, then the angle given is a right angle, and the angle given is an obtuse angle, just to make sure we cover all our bases. The given angle is one of the three, obviously. Let's start off with the acute angle. Thus it is required on this given straight line to draw a segment of a circle emitting an angle equal to that angle. That seems kind of impossible. We can try to do it with our imagination, but let's do it with our intellect. Okay. First thing we want to do is find middle terms. So let's say from this point, let's make an angle equal to this angle. We know we can do that on a given straight line and a point on it to draw an angle equal to a given angle. Okay, I'm going to use some different colors here. So let this angle be equal to this angle. Yeah, I mean, that's what we drew it that way. Great. Let's bisect our given straight line. And given a line to bisect it. Great. Let's draw a line perpendicular. Let's draw a line perpendicular to this one first. On a given straight line to draw an angle equal to a given angle. In this case, our given angle is going to be perpendicular. Great. And after we bisected this is equal to this. Let's draw this here perpendicular. Great. And let's connect these two lines. Or these 2 points. Connect these 2 points with this line. Good. Now we have two triangles here. Remember we drew this perpendicular. So we have two triangles, this side equal to this side and this in common, so we can do side angle side. Two triangles, side angle side equal to side angle side. Therefore the base is equal to the base. It's enough for now, we don't need to say anything more. But this is equal to this. Therefore if we hold this point fixed and we draw a circle with it, it's going to pass through this point perfectly because these are equal. And they will become radii of the circle. Let's do that. Make it green, just for fun. And this is going to be a horrible circle. Great. And we'll have cut this line, obviously, right there. Let's connect these 2 points. Great. All right. Now we have, I've got to show some equality here in some way. Okay, good. We need to show that this line touches this circle. How do we do that? Well, we've got this being the diameter, obviously, because this is the center of the circle. So this is the diameter. And this was drawn, this comes out perpendicular from this because they were drawn perpendicularly. So here we have a circle, the diameter of the circle, and a line coming out from the end point of the diameter perpendicular. We've showed that if there be a circle, and from the point of the diameter, the end point, a line be drawn perpendicularly, that line will not cut the circle, but touch the circle. So this line touches the circle. Great. Necessarily. That is to say it's a tangent. Now here we have a circle with a line touching it, and a line cutting across. We know that it's going to create an angle equal to the angle in the alternate segment of the circle. We proved that from the previous proposition. So this segment emits this angle, therefore this angle and this angle are equal. But this angle was drawn equal to our given angle. So this is equal to this and this is equal to this. So two things equal to the same thing are equal to each other. So therefore this angle equals this angle. And that was what was required to do in this proposition. Given this line, to construct a segment of a circle emitting an angle equal to the given rectilineal angle. The second case, this is very much the same thing. The second case is just as, it's easier in case. Okay, what do we want to do here? Let's draw an angle perpendicular. How do we want to do this? From this point, okay. let's move our line. Let's move our line like this, just to keep in the same direction. It'll be easier for me to draw. So this be our line. Good, and let's draw an angle from the point. Let's draw an angle equal to it, okay? Great. Let's bisect our given line. This is our given line. Let's bisect it. Therefore, if we hold this point fixed, we swing it around, it's going to cut through that as well. We can do that in green again. I'm sorry for the ugliness of it. Let's continue this. We're going to do the same thing here. Okay, we know it's going to pass through both points because we bisected it. Therefore, this equal this is going to pass through it. Great. So therefore, this is the diameter. Okay, I'm going to put the center there. And here we have, from the diameter and the extreme point, a line coming out at right angles. Therefore, this line touches that circle. It doesn't cut it. Okay? Therefore, this line has been bisected here, and therefore this, I'm going to say this differently. This here, pick a random point. This is necessarily going to be equal to this. We showed that in the past. And in a semicircle, we showed that in that same problem, the semicircle that admits of an angle equal to a right angle. Okay? So here we have drawn the segment, the semicircle, admitting an angle equal to the given angle. How is this angle equal to that? Well, they're both right. That's easy enough. But you can also just do this. This is equal to this, and this is equal to this. Therefore, this is equal to that. They're both right. Easy. Okay, let's do it again here with an obtuse angle. So here's our given line. Let's draw an angle equal to the given angle, in this case. Great. Let's bisect our given line. Let's draw, I'm going to start using a different color here. Well, let's use black again. From this point here, let's draw a line perpendicular. Great. Now we'll start using a different color. From this point of bisection, draw a line perpendicular. Great. Let's connect these two. Okay. Therefore, we do side angle side again. Two sides equal to two sides respectively. Two sides equal to two sides respectively. And the angle they contain are equal. Therefore, the base is equal to the base. Therefore, these two lines being equal, if we hold this point fixed and swing it around, making a circle, it'll pass through that point perfectly. Let's do that. Make it in green again, I guess. Good. Okay, I'm cutting this here. Therefore, what do we have here? We want to show that this angle here will be equal to the angle in this alternate segment. So we got to show that this is the diameter. This cuts through it, and all these things are equal, this being the center. So the center is right here, this is the diameter. Therefore we have, and this was drawn at right angles of this, therefore on the diameter of a circle, a line has been drawn at right angles, therefore it touches it. Okay, that's kind of key, you want to show that it touches it, so that you can say the following thing, which we proved, that here we have a circle, and a straight line touching that circle, and a straight line, a line being drawn across, that will create angles, an angle equal to the angle in the alternate segment of the circle, okay, which is this. Here's the angle that we drew equal to this angle, okay? This angle was originally drawn equal to this angle. And this was proven that when it's extended now, it touches this circle that we made. Therefore, this angle will make, as we know, it will be equal to the angle in the alternate segment of the circle. Remember that? Boom, boom. Whatever line you draw where it touches, it's going to make an angle equal to the angle in the alternate segment of the circle, wherever you put that. So this angle is equal to this angle. Therefore, we have constructed on that given line a segment of a circle admitting an angle equal to the given angle. Oh, by the way, this angle is equal to this, and this is equal to this. Two things equal the same thing are equal to each other, so this is equal to this. Therefore, we have constructed, when it's an obtuse angle, a segment of a circle and meeting an angle equal to our given obtuse angle. We did it for right angle and we did it for acute angle. Therefore, we have shown that it is possible to construct on a given straight line a semicircle, a segment of a circle and meeting of an angle equal to a given angle. Quod erat faciendum. Thank you. Bye-bye.